Hello everyone. I have had many requests for solving limits of trigonometric function, and today I'm going to solve two more examples related to trigonometric function. Let's start with the first one. So the first one is asking for the limit of 1 plus sine x minus cos x over 1 plus sine of alpha x minus cos alpha x when x is approaching to 0. Okay, how we can solve this problem? Similar to all limits that we have solved so far, the first step is to plug in 0 instead of x. Therefore, if we plug in 0 in there, what we will see it's going to be 1 minus sine 0 minus cos 0 over 1 plus sine alpha times 0 minus cos alpha times 0, and this will result in basically 1 minus 0 minus 1 over 1 plus 0 minus 1, which will generate 0 over 0 at the end. Okay, so this is going to be an indeterminate form, and we have to use a form of simplification in order to solve this problem. And from there we have to use some sort of basically properties of trigonometric function and trigonometric identity actually. If we look at the top part in numerator, if we look in here, we have 1 plus sine x minus cos x, and actually we can rewrite sine x as sine of x over 2 plus x over 2, which means that it is actually sine of 2x over 2. Therefore, we can say the other form of this function is going to be in the form of 2 sine x over 2 cos x over 2. And we can do the same thing for the sine alpha x, and that will generate 2 sine alpha x over 2 times cos alpha x over 2. And the other component that we have in here is 1 minus cos x. So let me write it down as, so we have 1 minus cos x, and we can use the double angle or half angle identities. Therefore, it's going to be 1 minus cos x, which is going to be 2 sine squared x over 2, and the same thing can be written for 1 minus cos alpha x, which will generate 2 sine squared alpha x over 2. Okay, so that being said, we can actually plug in the new forms that we have for each of these terms in the function, in the limit, and then start solving the limit again. So let me put this function instead of what we have inside that limit. So it's going to be the limit of x approaching to 0, and then instead of sine x we have 2 sine x over 2 cos x over 2, and instead of 1 minus cos x we have basically plus 2 sine squared x over 2. And for the denominator we have 1 plus sine alpha x minus cos alpha x, and the same law is going to be used in there. Therefore, we will have 2 sine alpha x over 2 cos alpha x over 2 plus 2 sine squared alpha x over 2. Okay, so at this moment, we can use some sort of factoring in order to continue with solving of this problem. So what we can do, if we look at the top part, we have sine x over 2 and actually in both terms. So we can do the factoring as, and this 2 can be cancelled from the top part. So we can say from the top and bottom part, and we can say it is actually sine x over 2 cos x over 2 plus sine of x over 2, and on the bottom we will have the sine of, don't forget the limit, so it's going to be the limit of x approaching to 0, and what we have to do now is going to be the sine of alpha x over 2, and then we have the cos of alpha x over 2 plus sine of alpha x over 2. Okay, so what we got here is actually the term related to these functions, and we just simplified it in the form that can be actually solved. Now we have sine x over 2, we have sine alpha x over 2, and then inside this parentheses we have cos x over 2 plus sine x over 2, and the other one is going to be cos alpha x over 2 plus sine alpha x over 2. And if you remember, we had some sort of properties when we have the limit of, for example, sine x over x when x was approaching to 0, which was equal to 1. And we can use this actually property here, and in order to do so, we can make this sine x over 2 and this sine alpha x over 2 in that form with just multiplying x over 2 on the top and alpha x over 2 on the bottom, and then returning the other terms on actually on the back of this whole function. So what we will have, let's go to the next page. What we will have at the end is going to be in the form of 1 over alpha, the limit of sine of alpha x over 2 over, sine of x over 2, sine of x over 2 over x over 2 over sine of alpha x over 2 sine over, this is 2 alpha x over 2, and then the limit 1 over alpha x approaching to 0, and inside the parentheses we have cos of x over 2 plus sine x over 2, and here we have cos of alpha x over 2 plus sine of alpha x over 2 when x is approaching to 0. What we can get in here, so sine of x over 2 basically for the limit using that property that I discussed is going to be 1, and the same thing will happen here, it is going to be 1. If you plug in 0 instead of x in these two functions on the top, it's going to generate 1 plus 0, and actually it's going to be 1 over alpha, and then we will have times 1 plus 0 over, and on the bottom again if we plug in 0 it's going to be 1 plus 0, and the answer at the end is going to be 1 over alpha. Okay, let's review what we did for solving of this problem. Initially we had a function in the form of 1 plus sine x minus cos x over 1 plus sine alpha x minus cos alpha x, and we noticed, okay, if we plug in 0 instead of x in there, it is going to generate an indeterminate form which is 0 over 0. Okay, but for 0 over 0 we have to use simplifications, actually algebraic simplifications, and because we have trigonometric function inside this problem, what we have to use is some sort of trigonometric identity, and we did that for actually finding the top parts in a new form that can be actually resulting in a good solution at the end for us. So then instead of 1 minus cos x, we have used 2 sine squared x over 2, and instead of sine x, we actually used 2 sine x over 2 times cos x over 2. And we plugged in this information, this new functions, instead of the functions that we had inside the limit, and we move forward with the steps of simplification to find the final answer of this problem. Again, one important point is you have to look at the trigonometric identity. You have to be fully familiar with the trigonometric properties in order to solve these kinds of problems in your assignments, exams actually. Let's look at the second problem that I have for today, which is the limit of tangent of x minus 1 over cos 2x. So we have tan of x minus 1 cos 2x, and again we have to use some sort of basically the properties of trigonometric function. And easily for tan of x we can write, let's do the first step. If we plug in pi over 4, tan of pi over 4 is 1, we know that, so it's going to be 1 minus 1, which is 0. And if we plug in pi over 4 in the function of cos 2x, it's going to be cos 2 times pi over 4, which generates actually cos pi over 2, which is 0. So the function is going to be 0 over 0, which is an indeterminate form. And what we have to do again, simplifications, and for these simplifications we need to use basically the properties of trigonometric function. Now it's going to be the limit of sine, so I'm going to do the simplification. It's going to be the limit of sine x over cos x minus 1, and for cos 2x again we can use the identity and some sort of properties of the trigonometric function actually. And what we can write for that, basically cos 2x is equivalent of cos squared x minus sine squared x. Now instead of cos 2x I just plug in this function here, so it's going to be cos squared x minus sine squared x when x is approaching to pi over 4. Okay, now we have x approaching to pi over 4, we have a new function, and we have to try to simplify it as much as we can in order to solve this problem. So the first thing, for the top we can get the common denominator, so it's going to be sine of x minus cos x. Let me use another color. So it's going to be the limit of sine of x minus cos of x over cos of x, and then here we will have cos squared, the limit sign here, x approaching to pi over 4, and it's going to be cos squared x minus sine squared x, and then we can write it as the limit of sine of x minus cos of x. And what we can do is we can just expand cos squared x minus sine squared x as cos of x minus sine of x, and then cos of x plus sine of x, and the whole thing is going to be multiplied by cos x, and x is approaching to 0. As you see, we have sine of x minus cos of x on the top, and we have cos of x minus sine of x. In order to generate the same thing on the top and the bottom, I'm just going to multiply this with a negative, or with actually minus 1, and then it is going to be the sine of x, the limit of sine of x minus cos of x, and underneath we will have minus sine of x minus actually cos of x, and then it is going to be sine cos of x plus sine of x, and the whole thing is going to be multiplied by cos of x on the bottom. Okay, so and x is approaching to 0. Sorry, x is approaching to pi over 4. I wrote it wrong here. It's pi over 4. Pi over 4. Okay. Now what we have in here is a sort of simplification that can easily result in the final answer. So what we have to do is just cancel the top and the bottom part, which will generate a limit of 1 over minus cos of x plus sine of x times cos of x, and x is approaching to pi over 4, and now it's time to plug in pi over 4. And if we plug in pi over 4 inside this function, it is going to be, let me see what we have. So we have 1 over minus the actually cos of pi over 4 is a square root of 2 over 2 plus sine of actually this function, sine of pi over 4 is a square root of 2 over 2, and then it's going to be multiplied by square root of 2 over 2. So the answer, this is going to be 1 over a square root of 2 times square root of 2 over 2, and the final answer, we have a negative sign here. The final answer is going to be minus 1. Okay, let's review the step, actually the steps that we had for solving up this problem. We had tan of x minus 1 over cos 2x. So, and first we plug in pi over 4, and then we noticed, okay, that is going to be 0 over 0, which is an indeterminate form. And what we have to do for the indeterminate form, like 0 over 0, we have to use some sort of simplifications. And in order to do those types of simplifications, here we are dealing with a trigonometric function. We have to use the properties of trigonometric functions and the identities related to those functions. And accordingly, what we did, we just actually used those properties and identities and plugged in those actually new forms inside this function, and after a few simplifications we could obtain the answer of this problem.